In this video we're going to fix these two power supplies. So these are just these standard LED power supplies that you'd find on eBay or AliExpress. Both of them failed while I was using them in this LED ceiling lamp that I had built. The larger 20 amp model just blows the fuse whenever you try to use it, while the smaller 10 amp model just doesn't produce any output power at all. I'll start out by opening up these power supplies, and they are all pretty much built the same way. They have two screws on these steel shrouds and two hooks on the back here where they hook into the aluminum case. And after unlatching the steel shroud, you'll be greeted by all the components on the PCB. A little note about safety here. These power supplies have huge capacitors in them that are charged to 400 volts or more. They keep the charge for many hours, days, or even weeks after you've last used them. So before you start working on the PCB or touch any of the traces on the bottom, make sure that those capacitors are discharged. So these power supplies are basically all built in the same way. They have some input circuitry over here, they have these two bulk capacitors to smooth out the AC to DC, they have these switching transistors back here, then their main chokes and transformers on this side, and then some output filtering on this end. The parts in here that are most likely to fail are these input NTCs, the two bulk capacitors, the switching transistors, or some of the output capacitors. In the case of the 20 amp model, it is fairly obvious that the inrush limiting NTC has burnt up. For the 10 amp model, we can see that both switching transistors are pretty badly burnt up. So we're going to replace those for the 10 amp one and the inrush limiting NTCs on the 20 amp model. The PCB on these is only directly held in by one or two screws, but you also need to undo the clamping mechanism for anything that contacts to the side of the case. For the 20 amp model, this is the area that we're going to be working on. I've noticed that the rectifier is also poorly soldered, so I'll try to redo that one while we're at it. Just one last time, I'm checking that the input capacitors are actually discharged. These NTCs are contacted to these four spots on the bottom, and I'll start out by clipping off the main housing on the top so that we can pull out each of the legs individually. For desoldering, I like to use a thicker tip at a higher temperature because that's going to allow me to pump as much energy into the solder joints as possible. This means I'm not going to be burning up the area around them, but only melting the solder as quickly as possible. I'll start out by chucking this PCB into a vise just so that it doesn't fall over on its own. These legs come out fairly easily by pulling with a pair of pliers from one side and heating up the solder joint on the other. And while we're at it, I wanted to redo the soldering on the rectifier, so I removed as much of the old solder as possible, cleaned up the contacts a bit, and then resoldered it with plenty of flux and good solder. It didn't come out perfect, but I think at least it's gonna make better contact than before. Some of the solder points where we're going to insert the new NTCs were still kind of messy and plugged up with the old solder, so I cleaned them up with some solder wick as well as I could. To solder in the new components, I popped them through from the top and then bent their legs over on the bottom side so that they'd stay in place and wouldn't fall out. Always make sure you bend these legs in the right direction so that they don't short out to any adjacent tracks. I kept using the large tip on the soldering iron for this, and the soldering process went really well. Now to reinstall the PCB into the case, I reused all the thermal pads to contact the components to the aluminum case and tightened them down with the original sheet metal bars. Then installed a single screw on the PCB and double checked that the voltage switch was in the correct position. That's 230 volts for me. And before testing this PCB for the first time, I wanted to make sure that the sheet metal casing was also on there, just to make sure that I wouldn't accidentally touch any of the high voltage parts inside. It clips into the aluminum shell with the same two clips and gets two screws on the opposing side. Because I didn't have an open-ended mains cable at hand, I quickly made one from an IEC cord and crimped on some fork spade connectors. I can really recommend these simple crimp connectors. They're cheap, they're easy to use, and they make your wire end so much more professional and durable. So this is the moment of truth. Before the repair, this power supply would just blow the fuse as soon as I plugged it in. And now, it works. A quick check with the multimeter confirms that we have a solid 12 volts on the output. Repair successful. Alright, we get the 20 amp power supply back in action. Let's see if we can fix the 10 amp version just as easily. Now this power supply is built in much the same way as the 20 amp version. In this case, both of the switching transistors are visibly blown, so I'm going to start by replacing those. Again, I'm double checking that the bulk capacitors are discharged before I start working on this one. Clipping off the legs of these components makes them much easier to remove because you only have to heat one of the pads at a time instead of all three. It also reduces the risk of damaging any of the tracks because it can be much more careful when desoldering them. This kind of vise keeps in come in handy for all sorts of projects, and in this case I'm using it to orient the PCB horizontally. Before inserting the new components, I again clean up all the solder pads with some solder wick to open them up. Then it's the same process as before, drop in the components, bend the legs over and snip them to size. With the large tip on the soldering iron, these solder joints came out beautifully and it's time to drop the PCB back into its case. This one was a bit tighter than the other one and it felt like it never really snapped into place, but in the end I did find a spot where it felt right. The manufacturer of these power supplies likes to use thermal paste with the thermal pads, which is absolutely not necessary. As long as the components themselves make good contact with the pad, you don't need to worry about the thermal paste at all. One last check if the input voltage is set correctly on the internal switch and the sheet metal shroud can go back on. Alright, time to plug it in. And it's looking good, it's not blowing any fuses, it's not setting off any blue smoke or anything, but unfortunately when I checked with the multimeter if it was actually generating any output voltage, there was none. So something else is still broken inside this power supply. So as one last check, I opened up the case again and checked if the internal glass fuse was blown, but it looks like that one is still in perfect condition. I'm guessing something else must have taken a hit when the transistors blew out. So unfortunately we didn't get this 10 amp power supply fully functional again, but we did manage to repair the 20 amp model completely. It seems to be functioning as good as new. The parts for these repairs were very inexpensive. This 50-piece bag of NTCs, that was the part that was defective in the 20 amp model, this was $2.50, and a 10 pack of transistors for the 10 amp model was $3. So very inexpensive repairs, and even if they don't work out, you're not wasting a lot of money. So I'm not sure if it's worth putting any more effort into the 10 amp model, but I guess the one takeaway from this is to not use these cheap power supplies to their full rating. So if you need 10 amps of load, maybe go with a 15 amp model instead of the 10 amp one. Any similar repair like this, where it's just a power component failing or burning up, should be fairly easy to repair. The parts are very easily found on AliExpress. I'm putting the links to these transistors and the NTCs in the video description below. So I hope you learned a thing or two from this video. If you did, give it a thumbs up. If not, give it a thumbs down. If you want to see more videos like this one, get subscribed obviously. And if you feel like directly supporting what I'm doing here, head over to Patreon and chip in $1 or $2 per month and you'll get access to monthly Q&A hangouts and more. That's it, thank you for watching and I will see you in the next one.